Good evening, ma'am.
So yeah, we'll wait for around 7 to 5 minutes for everyone to join. So today we'll be seeing week 7 summary and also we'll be solving problems.
Good evening, ma'am.
Yeah, good evening. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay, thank you. Yeah, have you guys gone through week 7 lecture?
Ma'am, sorry, what?
Did you guys go through week 7 lecture?
Ma'am, not completely.
Oh, it's okay. But you have started, right?
Yes, ma'am, a bit.
Okay. So basically in week 7 we will be seeing low pass filter, high pass filter, band pass filter. So we'll be seeing filter and its responses both by in terms of theory and practically. Practically I mix through some experiment. It would have been explained in one video, and in the corresponding video the theory related to that will also be explained. That's how the lecture will be. Then we will also see what is first order analysis,
Okay, ma'am.
and we'll also see its limitations. So what we saw in the week 6 is there is a Vn, there is a resistance R and capacitor C. Given Vc of 0 minus is equal to 0. What is Vc of t when a step input is given? Step input is given as an input signal to a RC circuit, and the voltage across capacitor is measured. What is the output?
Ma'am, it is Vn or V naught into 1 minus C into.
Yeah, C, once we apply this value, we
Yes,
get
ma'am. Sorry,
yes
sorry.
minus 1. Yes,
Minus T by RC.
yes. Its unit is volt since it is a voltage.
Yes, ma'am.
So basically, it's so with respect to t, this is my input signal, right? At time t is equal to 0, it becomes u of t. This is my Vn. But my response will be like at time infinity, Vc of t will be equal to V naught. But initially it will be exponentially increasing, right? This is my Vc of t. So if this point is Vm, so there is a point at which it reaches Vm by 2. What is this t?
Point 693 RC.
Yeah, 0.693 RC, right? And RC we will also call it as time constant, right? Tau. So the same circuit. So yeah, this is what we saw for this. This is step input response, right?
Yes, ma'am.
This is what we saw in the 6th lectures last. Then the same circuit we will take. R and a capacitor connected across it, C. This is my V in, and I am going to measure Vc of t. Here also given Vc of 0 minus is equal to 0. But here instead of step input, I am going to give a sine wave. And I am going to read how my output will be.
And so what will be
Okay.
the difference with sine wave and step input?
These are just different waveforms. Step input means it will be 0 till time 0. Then once time 0 is reached, it will reach its magnitude Vm. If it is a unit step response, it will reach 1. If it is just a step response, it will reach its Vm. Whereas sine
Okay,
wave is,
sine wave will be in form of sine.
yes.
Oh,
So basically we are going to give different inputs, and we are going to study how this circuit responds to that inputs and how my Vc of t is.
okay, ma'am.
First, we'll be seeing an experiment based. So when I give a sine wave as an input and I measure a voltage across a capacitor, So this you would have seen in lecture 7.1, right?
Yes, ma'am.
V in frequency. Then Vc of t amplitude. I'm going to measure. And if you see, as time goes on, as I change the frequency, there is also a delay observed in that. So I am going to increase the frequency from 100 to 50K. My input voltage is 1 volt. If you see the output, it actually is 1 volt at 100 hertz, but the amplitude reduces to 0.1. Whereas initially there will be no delay, and as I increase the frequency, the delay will be approximately pi by 2.
Ma'am, this is experiment basis, no?
Yes. So input is a sine wave, right? The sine wave will be in the format Vm sine omega t plus phi. So what I'm doing is
Yes,
I'm
ma'am.
fixing my Vm as 1 sine. This omega I'm varying, and phi I'm giving as a 0. 0 phase 1 sine omega t. This omega I am varying with this frequency.
Okay, ma'am.
Omega is nothing but 2 pi f, right? So this is
Yes,
my
ma'am.
f value. As I increase the frequency, my omega will also increase. As I increase my omega, I have observed that the voltage across the capacitor is reducing. And there is also a delay. The delay in the sense, if this is a sine wave I give as input, as omega increases, my circuit is going like this. So basically it starts at a point here. Okay? It's basically the phase difference between the two waves. So when I give an input as a sine wave, Vm sine omega t, and a resistor R is connected in series and a capacitor is also connected in series, I am assuming the capacitor is initially discharged. The voltage across the capacitor is Vc of t. As omega increases, Vc of t decreases. And also delay also increases. Okay? So this is my observation, right?
Ma'am,
After
delay
that
is basically
experiment.
phase difference.
Yes.
Phase difference
So
in input voltage.
yes, phase difference, right? So it is the phase of the output voltage with respect to
Okay, okay.
input voltage. The
Okay,
difference
ma'am.
between the two waveforms.
Okay, ma'am.
So if I draw the frequency plot with respect to omega Vc of t, initially it is high, but as omega increases, it is moving down, right? I am plotting this both.
Okay, ma'am.
So
Ma'am,
this
basically,
circuit
if an
basic
input voltage, the omega increase, so Vc of t will decrease.
as omega increase, Vc of t decrease. Yes, it allows low frequency signal but blocks high frequency signal, right? Shall I say it from this graph?
Yes, ma'am. Because when omega is maximum, then Vc of t will be 0.
Yes. So this circuit, I'll call it as low pass filter because it is allowing the low frequency signals and it is blocking the high frequency signal. So I call it as low pass filter. Is it clear?
Okay, ma'am. Ma'am, so in low pass filter, the input voltage should also be in the form of sine wave.
No, this, see, it needn't have to be a sine wave.
It
We
can
need
be any
something,
waveform.
yeah, anyway with some frequency.
Okay, okay, okay.
Square wave
Okay,
can also
ma'am.
have
Because,
frequency, right?
ma'am, because in the step input there was no frequency. That's why.
Yes, that's why we are going. Yeah, yes, exactly. So, yeah, that's why we
Okay.
are to analyze the frequency. We are using sine wave.
Okay, ma'am. Okay, ma'am. Ma'am, so
Ma'am,
if we
can
replace this waveform with just a step input, then it becomes a normal circuit, which we was solving in week 6.
Previously. Yes.
Okay, ma'am.
yes.
Okay, ma'am.
Ma'am,
Thank
can you tell us a little bit what you studied? Because I'm joined late. Sorry, ma'am.
Yeah. Okay. You want me to revise, right?
Yes,
Yeah.
ma'am. Because if we
So
taught us a new topic, then I will not able to understand.
So basically, I'm giving week 7 summary, okay?
Okay.
So in last week, we saw about the step input response, right? When a
Yes.
V in, which is a step input, is connected across a resistor and a capacitor, and given VC of 0, initially the capacitor is discharged, and I'm measuring the voltage across the capacitor. This is the formula. This we know by week 6 lecture itself, right?
Okay. Yes.
The same circuit I am taking, RC circuit, V in, but instead of the step input, I am giving a sine wave. We know sine wave is
Okay.
nothing but Vn sine omega t plus phi. And I am
Yes.
fixing Vm as 1 volt and phi I am giving as 0, Vm as 1 volt. What I am doing now is I am going to change omega. I am going to change the frequency of the input
Frequency
signal.
of the yes.
Yes. Omega is nothing but 2 pi f. So if I change f, I am going to increase f from 0 to 50k. So if I increase f, omega will also increase, right? So
Yes.
basically, I am increasing the frequency of the input signal from a lower value to the higher value. Then I am measuring the VC of t. That is, I am measuring the voltage across the
Volt
capacitor.
across the capacitor. Yes.
Yes. So
Okay.
initially at low frequency, it is giving me the exact 1 volt. But as I increase my omega, that is my frequency f, my VC of t is decreasing. That's why I observed experimentally. Okay.
Yeah. Because the capacitor takes a time to charge,
Yes.
and we increase the frequency. That's why it cannot charge too much fast. That's why.
Yes. Right. Exactly. Then
Okay.
at the same time, if you see, there is also a delay between the input signal and the VC of t. That delay is
Yes,
also
ma'am.
increasing with omega. So delay
Yes.
is nothing but the phase difference. That's what I said. So this is what we observed. As omega increases, so basically we are increasing f. If f increases, omega increases. If omega is increasing, I am observing that VC of t is decreasing in this circuit. And also there is a delay that is evidently shown. Then
Ma'am,
also I'm
delay
plotting.
is because of a time taken by capacitor to take a charge.
Yes.
That's why.
Yes.
Okay.
The delay is like as see, this is the input voltage
Yes.
and output voltage will be like this. So there is a delay, right, between these two signals.
Yes, ma'am.
So that we call it as phase difference. Phase difference is what here they mentioned as delay.
And ma'am, we cannot use here an square wave.
Yeah, you can use square wave also.
Okay. We can see difference there also, because professor did with square wave.
Okay. So what I'm plotting is in
Hey,
x-axis I'm
sorry, excuse me. Can you go back to that sine wave with the delay that you have shown? Yeah, no. Yeah. So which one is the input? So input is one which starts at 0. The other one is delayed, but I see that, yeah,
so delay is just they used it to represent it. It's basically the difference between the phase difference is like
shouldn't it
what
be
can I say?
lagging? So it should
No, V
reach.
out is leading, right?
Oh, okay. Right. Okay, got it.
Okay. If it is like this is A wave. I am giving you another wave, which is like this. So B. Here actually it is A is leading, okay, A is lagging behind B and B is leading A. Right? Because at time t is equal to 0, when the sign A is at 0, it has already completed some of its waveform. So this phase difference and all you will be seeing more in EEC. Here, if you know the basic idea of what is phase difference, that's enough. And what waveform is leading or what waveform is lagging. So yeah, as I was saying, so I'm going to plot these two variables. As I increase my omega and I'm going to see how my BC of T is. So I will get like this waveform. So what this waveform say? It basically allows the low frequency signal and it is blocking the high frequency signal. So because of these characteristics, this circuit is called as a low pass filter. Is it clear? Do anyone have any doubt till here?
What is low pass filter? Yes, ma'am. Low pass filter, because the resistor is connected in series, so it draws little bit power. That's why high frequencies stop and low frequencies go through it.
Yes, it's basically allowing. See, this is omega frequency. It starts from 0
Yes.
to infinity. From the low values, it is allowing, whereas high values, the VC of T is reducing. So it's basically blocking high frequency signal. So it is called as a low pass filter, right?
Yes.
So yeah. Next, what you will be seeing is low pass filter. The same here, Vin of T is equal to Vm sine omega t, resistor, capacitor, RC. We are going to derive an equation for Vc of T. And it will be a big derivation. Do you guys want me to go through the derivation or you want to know only the N formula? Did you
I
guys
want only
go-
formula.
Okay. What about others? Okay. So what my actual point is, did you guys go through this low pass filter theory video? Did you guys have any doubt in the derivation? Because the professor would have explained the full derivation. So yeah, then now for now I will just give you the final derivation answer. You can go through the lecture, understand how they have derived it. If you have any doubt in the derivation, then you can come and ask. Okay, is it fine?
Yes, ma'am.
Okay. So Vc of T is nothing but A by root of 1 plus omega square R square C square sine of omega naught T. Okay, this is omega naught minus phi. And also phase difference is equal to tan inverse of omega naught RC. So this is the formula when a sine signal is given. Is it okay?
What,
Yes,
ma'am?
ma'am.
When sine signal is given, then we had to put their frequency.
When
Omega.
sine signal is given, this is the formula for Vc of T. This Vc of
Okay.
T's formula is this one. Then
Okay,
I told you, right? The capacitor
Okay,
will have a
sine
phase
is
difference.
given. Sine frequency is given then.
Is my voice audible? Hello?
Yes, ma'am.
Yeah. So what I'm saying is when the input is a sine signal, you have to use this formula.
Okay. To find a voltage across or
Capacitor, yes.
cap, yes.
We already saw, right? When there is a step input, Vm u of T, RC, Vc of T. Here we derive Vc of T is equal to Vm 1 minus e power T minus T by RC. We derive this equation, no? This you should apply only when there is a step input. Once the input is sine signal, you should use this formula. Is it clear?
Okay, ma'am.
Yeah.
Wait a minute, ma'am. I have to write.
Yeah.
So what is A here?
Amplitude
A
maybe.
is the wait. Okay, A is the it's actually it's not Vm sin omega t, it's A sin omega t.
Okay.
It's just
Amplitude of the
amplitude of
input.
the signal.
Yeah.
Ma'am, A is amplitude, na?
Yes,
Okay.
amplitude of sine wave. Pi is you will find using this for tan inverse formula. Omega naught you can take it from the question, angle of frequency, the same omega. Then RC you can take it from the circuit. Yeah. All clear, right? Yes.
Yes.
Now we will analyze this equation. So I'm going to take only the magnitude a by root of 1 plus omega naught square r square c square. So if omega is very low, what happens when omega is very low?
Capacitor charge fully, then high pass signals will pass through it.
Yeah, when
Then
omega
when
is very low,
basically A out is basically equal to A.
yes.
Yes.
I'm saying is omega naught RC will become very less than 1. So root of 1 plus it will be equal to 1. So A out is equal to A. If omega is very large, any large number like infinity plus 1 will give just infinity, right? So my A out will become A by omega naught RC.
What you write then if omega is lower than W naught, omega naught RC, then
Is very much less than 1.
okay.
So from this itself we can see, right? At low frequency A naught is, this is my amplitude, this is my omega. Initially it is A and it is reducing like this.
If omega is larger.
Is omega goes larger, very large, like see here if omega is increasing, what will be
Infinity,
my
yes.
A naught? It will be reducing, right?
Yes.
That's it. That's why the graph is in this trend. And also there is another one formula to find the cutoff frequency. It is 1 by 2 pi RC.
Cutoff frequency for
Okay.
what, ma'am? Across the capacitor or across?
No. This is like cutoff frequency. If I'm going to design a low pass filter, there is if this is not F and this is C, there will be something called cutoff frequency. So if I'm going to design a low pass filter, I want to design a low pass filter that allows till 15 kHz. So if I want to design like this I call it as cutoff frequency.
Okay.
So
More
according
than
to
that,
this
it will
formula,
not allow.
allow, yes. I
No.
will actually
Okay.
select R and C depending on this equation. That is what F naught
So
is equal to 1 by 2 pi RC.
it is only for low pass or high pass both.
The same equation is applicable for high pass filter also.
Okay.
So wait, yeah, once you understand high pass filter, it will be easy for you to understand this also.
Yes, ma'am. I know.
So there is mainly only one formula, no? If you have to remember.
Yes, there are 3 formulas, no? This VC of t, this phi, and this F naught.
Cutoff frequency.
Yes.
Ma'am,
Then
can
what
you
about
show a bit
cutoff angle
upper?
of frequency?
There we had to just use the omega now.
Can you again tell that how cutoff frequency is calculated?
Okay. So this is my cutoff frequency, FC or F naught. So within this it will allow, after that it will not allow. So this is a frequency, it's like a point below which it will allow, after that it will not allow. That point we call it as cutoff frequency. And omega is nothing but 2 pi F naught, right? So
Yes,
it's
ma'am.
just 1 by RC.
Okay, ma'am. Okay.
Now, in the same way, we are going to see about the high pass filter. So for that, the same thing I will take. There is a step input given to a R and C signal, R and C circuit. And I know the voltage across the capacitor is nothing but, if this point is Vm u of t, it is Vm 1 minus e power minus t by Rc. Given initially the capacitor is discharged. Now, what is the voltage across the resistor? Vr of t. How to find Vr of t? We can directly apply KVL, right?
Yes, ma'am.
V in of t minus Vc of t. Is it right?
Yes, ma'am.
So
And
1
basically,
volt.
it is the case of step input, na?
Yes. Vm e power minus. Okay. So it's basically Vm 1 minus e power minus t by Rc. Yeah, give me a minute. I'll be back. Yeah, 1 second. I'll be back in 2 minutes. Yeah, sorry guys, I had to take a call that side. So yeah, we'll continue. So what happens now?
We
So
are
it's
finding
just
voltage
Vm
across the resistor. Yes.
e power minus t by Rc, right? So Vm will get cancelled. So Vr of t is nothing but Vm e power minus t by Rc volts, right? So summarizing,
Yes, ma'am.
if there is a step input with Vm given across a resistor and a capacitor, this is Vc of t, this is Vr of t. Vc of t is nothing but Vm 1 minus e power minus t by Rc. Vr of t is nothing but Vm e power minus t by Rc. So this is exponentially decreasing, right?
Yes, ma'am.
So we will just
Ma'am, so in
draw.
high pass filter, we will use a step input, not waveform.
No. Actually, see, before learning with a sine wave, you have to understand with step input, no? Then only it will be easier, right? That's it.
Okay.
So this is my input. And this is my Vc of t, right? And my
Yes, ma'am.
Vr of
And
t will be
VR of t is decreasing.
exponentially decreasing. And also we can note the intersection point is nothing but, what is this point? It is the time taken to reach Vm by 2, right? So that is also the point where these two waveforms meet. Is it clear?
High pass and low pass both meet at the one point. That point.
Yes.
So
So
VM
VC
is,
will be
what is my VM by 2?
Vm. So at this point, if you see the amplitude, it will be exactly Vm by 2.
Okay.
Half of the peak
Yes.
amplitude. So what does this graph say? So if I am giving a DC signal or a step input, initially the voltage across the resistor is high, right?
Yes.
As time goes on, the voltage across the capacitor will become Vm, right?
Yes.
So this is one thing you should remember. Yeah. Now,
So it is we are discussing about now a low pass filter or high pass filter.
now we are high. Okay, yeah. Now only we are going to high pass filter.
Okay.
Till now, what we saw is what happens to the resistor when a step input is given.
Okay, inside the resistor.
Okay.
Yes.
What happens to the voltage across the resistor? Now,
Okay.
I am going to give a sine signal V in of t, Vm sine omega t, R C, and I am going to measure the voltage across the resistor.
Hmm.
The same way, VR of t is equal to V in of t minus Vc of t. It is nothing but A sine omega naught t minus A by Vc of t. We have already saw in the low pass filter, right? R square C square sine omega naught t minus 5. Phi is same. Tan inverse of R omega naught RC. Now what happens when omega naught is small? How will VR of t will be?
Omega naught is small, then it is suppose V in
One
is equals to
second,
V
we'll
out.
just take the A out.
Okay.
Only the amplitude will take.
So, ma'am, A out will
Out
be
will be
0.
0.
Yes. A out will be equal to 0. When omega naught is large, A out will be
A will be equal to A.
A, yes. Alright?
But when
So if
omega is large, the frequency is large, then across the resistor.
omega naught is large means this is all for resistor, across the resistor.
Okay.
So at low frequency, it is 0 and gradually it is going to A. So it basically hallows high frequencies and blocks low frequencies, right?
Yes.
So it is a high pass filter. So in short, the same circuit, you are giving the same sine wave. If you take the voltage across a capacitor, it will be a low pass filter. If you take the voltage across the resistor, it will
Resistor,
be a high
it is
pass
high
filter.
pass filter. Yes.
So I will just reform the circuit and I will low pass filter, high pass filter. So if it is RC, this is my V in. If I am taking V naught of T across the capacitor, it is low pass filter. If I am taking across the resistor, it is a high pass filter. Is it clear?
Yes, ma'am.
And my
This
graph will be,
this diagram is easy to understand what we are
yes.
talking about, because when we take a one diagram to explain both, it will be like confusing.
And what is difference in both these? Like V naught of T. So how V naught of T tells which one is low pass, which one is high pass?
Yeah, see, here it is RC, where here it is C and R. The orientation is changed, right? This V naught of T is the voltage across the capacitor. Here V naught of T is the voltage across the resistor.
In high pass, we are
Okay,
finding
ma'am.
voltage across capacitor. In low pass, we are finding voltage across the resistor.
Yes.
Or can we
So there will
say
be,
low pass filter, you change the capacitor to filter the frequencies that you don't want, and in high pass filter you change the resistor to filter the frequencies that you don't want.
no, in both you
No?
will change both R and C.
Okay.
So the cutoff frequency is same. FC is equal to 1 by 2 pi RC.
Yes.
If you want a high pass filter, you will take a voltage across the resistor. If you want a low pass filter, you will take the voltage across the high pass capacitor. Is it clear?
Okay.
And simple frequency is equals to 2 pi
Here
RC.
also, if it is 15 kHz, here also 15 kHz. For low pass filter, you will take the voltage across the capacitor. For high pass filter, you will take the voltage across the resistor.
Okay.
That R and C can be any values.
Okay.
Like if you want to design one low pass filter, then you can choose R and C according to your own wish, such that FC will be 15 kHz.
Okay.
And ma'am, omega is 2 pi RC, na ma'am? Angular frequency is equals to.
Angular frequency is equal to 1 by RC because
1
it
by
is 2
RC.
pi F. So 2 pi by 2 pi RC, 2 pi will get cancelled, so it's 1 by RC.
Okay.
So basically, high pass filter and low pass filter, the difference between both, basically, if we are making them, so just just the voltage we are taking across which
Yes,
capacitor or
that
resistor
determines what type of
makes a
filter you are
difference.
using. Yes,
Okay, ma'am.
exactly. So that's why understanding the step response will make it easier for you to understand when a sine signal is given. Once you understand low pass filter, understanding high pass filter is very easy.
Okay, ma'am.
Now, what if I want a waveform? Omega amplitude, which is like this.
And so I think now we will connect both of these.
This
Yes.
is band pass filter.
Yes, this is band pass filter. Now you have to tell me what is the cutoff frequency of the high pass filter, and if I say this is 5 kHz and this is 15 kHz, tell me which is the cutoff frequency of the high pass filter
15
and
kHz,
which
ma'am.
is
5 kilohertz.
5.
yes.
Okay,
This is
cutoff.
for high pass filter.
Okay, it
And
cut.
low pass
And
is
this is
50.
Yes, yes. Sorry.
because this will allow lower values.
Yeah, and it
For high
will
pass
stop
filter,
that
yes.
5 kilohertz. Yes,
Yeah, right?
yes.
So it
And
is
then what if
basically
the cutoff frequency of both becomes same?
if you are designing a circuit, then you want it to be 5 kHz, something like this, right? So only at 5 Hz it should give signal. You want to design circuit like this. So something like this it will what happen. But usually we will not design like that. Because see, ideally if I am going to design a filter, my low pass filter will be like this, such that At omega c, after till omega c it will be perfect 1. After omega c it should give me perfect 0. Same way as high pass filter. These are ideal filters, okay? Till omega c it should be 0. After that it should be a perfect 1. Band pass filter also 0, 1, 0. So these are ideals, okay? But in real life, achieving ideal is very tough. Also, having only one R and C, you will have this gradually decreasing only because of the delay of the capacitor, okay? It will be gradually increasing and gradually decreasing. That is all because of this resistor and capacitor. So what they will do is, they will connect one more RC. Once you connect one more RC, the waveform will be similar. It will be like more steeper. The moment you connect one more RC, this will go deeper. So as you go on increasing the R and C count, this you will be getting more and more real to ideal thing. But what is the issue in connecting many RC? Are you guys
Many-
understanding the point?
Yeah, ma'am.
Yes,
If
ma'am.
you connect a many RCs, then it is like,
Complicated circuit.
yes, like an amplifier type of
Calculations will be
like.
complicated. It will become bulky. These are the complications also.
And
Yeah,
this type
what
of
will you see?
circuit we can solve using the superposition method.
No, how will you solve? There is only one source, right?
Yes. Yeah.
So
Okay.
basically, see, if there is one capacitor in a circuit, then it is a first order circuit. If there is a one capacitor and one inductor, then it is a second order circuit.
One capacitor and one inductor. The second order.
So basically, if you write the equation of this in time domain, so you will be having 1 Vin of t is equal to VR of t. VR of t is nothing but IR plus VC of t. VC of t is a
Yeah.
what
We
is Q is equal to CV. dq by dt is equal to CV dV by dt.
DT. Yes.
So this is nothing but current C dV by dt. The voltage is nothing but 1 by C integral I dt, right? Integral I dt, right? By C. So basically, there is one integration term. And if you just have inductor also in the circuit, it will become L di by dt.
Yes.
So there is one differentiation term, integration term, and the resistor term. So basically, once you increase the number of resistors or inductors are increasing, the degree of the equation will increase. So the order of the circuit will also increase.
Okay. So order defines a degree.
Hmm.
Okay.
So these are the limitations of first order circuit. What is the limitation of first order circuit? You will not have a perfect
One capacitor.
omega
One.
c. It will be gradually only going down. That is one limitation of this first order circuit. But the analysis is easy. The circuit will not be much bulky. Those are the advantages. But disadvantages is it will be gradually moving over the cutoff frequency. But once we decide to go to second order circuit or third order circuit, we have our advantages and disadvantages, right? So you have to choose a balance. You have to reach a balance between them and choose accordingly. That is what will be discussed in the last session. That is the limitation of the first order analysis. Now we'll come back to the band pass filter. So there is a high pass filter and a low pass filter. So simple. There is B in RC. You are going to cascade it with the CR circuit. R1, C1, R2, C2. And you will take the voltage across this point. So this you will design for 5 kilohertz, and this is a low pass filter. You will design it for 15 kilohertz. and this we will design it for 5 kilohertz. Right? Is it clear?
Yes, ma'am.
Yeah. So we'll just summarize and then we will move to problem solving. If my Vin in the circuit is a VM step input, what is my VC of t?
Vm into 1 minus e power minus t by RC.
What about my VR of t?
Vm minus Vc of t.
Yes.
Yeah.
So it is VM e power minus t by RC. Once this one is A sine omega naught t. What about my VC of t?
A upon under root 1 plus omega naught square r square c square into sine of omega naught t minus phi.
Yes. Here B of t is nothing but A sine omega naught t minus A by root of 1 plus omega naught square r square c square sine of omega naught t minus phi. So this is what the
Yes,
equation
ma'am.
when sine wave is given. Also
Ma'am,
some
in
other
this,
reason
there is
phi.
no such case like initial condition Vc of 0 equals to 0 or.
No, that will make the circuit more complicated, no?
Okay, ma'am.
Then what about my cutoff frequency? It is 1 by 2 pi RC. And omega c is equal to 1 by RC. Then also you have to remember, okay, so this VCT is low pass filter and VR of T is high pass filter, and combining both you will get band pass filter.
Band pass filter, yes.
So this is what we saw, right?
Yes.
Yeah.
Yes, ma'am.
We'll move to some problems. So there is a step input of 30 volts, okay, connected to a 4 k ohm resistor. Then there is a 0.5 millifarad capacitor. This is VC of t given VC of 0 minus is equal to 15 volts. So an RC circuit with resistor 4 kilo ohm, capacitor is 0.5 millifarad, is fed with a step input voltage of 30 volts as shown below. The initial voltage across the capacitor is 15 volt. You have to find the voltage, output voltage across the capacitor at time t is equal to 1 second.
Okay.
At time is equal to 1 second. Yeah, find and tell me. What is VC of t at time t is equal to 1 second? 15 volt, 30 volt, 4K, 0.5 milli. Also, this is for first question you have to find. The second question is, they are given at some particular point of time, VC of t reaches 25 volts. You have to find the time. Yeah. Find and tell me the answer.
First, we had to find the omega, ma'am. Omega naught frequency.
Why do you want to find omega naught? It is a
Because
step input, right?
Vc of t is nothing but amplitude upon square under root 1 plus omega square RC square.
What is the formula you have to use here? What is the question? Is it a sine input or a step input?
Yes, step input, ma'am. Sir.
So use the step inputs formula.
VM.
Yes. Take your time, calculate and tell me the answer for first question and then second question.
Yes, ma'am. Just calculate.
Yeah, yeah.
Is it 90.57 volt for first?
Yeah, please repeat again. What was the answer that you got?
90.57 volt.
Is it 19 or 90?
90.
No, you have to check it again.
Ma'am, 20.9 volt.
Yes, it's 20.9 volt. 20.9 is right. All the formula which we have used, we took VC of 0 minus is equal to 0. Then only you can use VC of t is equal to Vm 1 minus e power
Oh,
minus
yes.
t by RC.
20.9. Yes, 20.9. Yes.
Once the VC of c is some value, VC of t will be equal to Vm 1 plus c e power minus t by RC. You have to apply this condition, find the value of c, then you will get the equation, then you can find VC of t, right? Are everyone getting 20.9 volts? Those who have got 20.9 volts can move to the next question. Tell me what is the time taken for the output voltage?
Ma'am, 2.19 second.
Yes, right. 2.19 second is right.
Ma'am, 2.19.
Oh, okay, yeah. Yeah, a lot of them are leaving the meet. Is there any other meet scheduled at this time?
Yeah, ma'am. Today, 2 to 3 minutes are at the same time.
Oh, what are they?
Ma'am, Linux Lab 3 and C programming tutors.
Lab 3.
Linux and ESTC and C both.
Okay, okay. Yeah, everyone got the answer, right? Do anyone want me to solve? Otherwise, I'll go to the next question. I'll give you another one question. I hope no one has any doubt. You guys can solve it by yourself, right?
Yes, ma'am.
Okay. So again, there is one R and C. The R value is 10 kilo ohm and C value is 10 microfarad. First, you have to find the cutoff frequency. Cutoff frequency in hertz. This is the first part. Then the second part is given an input voltage ten sine 50t is given as input. Assume Vc of 0 minus is equal to 0. You have to find the voltage across the capacitor. You can find it, tell me.
Ma'am, in first question we had to find the cutoff frequency.
Yes. What is the formula that you will use?
Frequency 1 by 2 pi RC.
Yes, exactly. Suppose in the question they will be asking frequency, but in radian per second.
Okay.
What will the formula you use?
In radian.
In radian per second. It is nothing but
Ma'am,
omega
1 by
naught, right?
RC. 1 by
Yes.
RC.
So please look into the unit before using the formula. If it is
Okay.
hertz, use 1 by 2 pi RC.
And if
If
it
it
is
is a radian per
radian,
second.
then
Yes.
1 by RC.
Yes, exactly.
Ma'am, I think frequency in hertz will be like 5 upon pi, something.
Yeah, apply the value of pi and then find the answer, no?
Okay, ma'am. One second.
Yeah. Here, if you find VC of t, you'll be getting in some with sine value, right? You can just find only the amplitude.
So, ma'am, frequency in
Magnitude.
hertz will be like 1.592.
Yes, the answer is 1.59. It's right. You can find the magnitude of VC of t. Yeah, did you get the magnitude of VC of t?
Ma'am,
And so,
1.96 volt.
Yes,
just amplitude, no, we have to calculate.
1.96 is right.
So, and
Yeah,
this is
Samantha,
amplitude. So, if we
yes.
calculate complete, so sine of omega naught t minus y. So,
No,
how
this
we
is not
calculate
amplitude, it's
phi?
magnitude. Huh?
So,
What
sorry,
you
sorry,
what you
sorry.
want?
It this so with this magnitude, we have also to calculate na, like sine function also.
Okay. That is if you want to find VC of t, you can just find phi value and your answer will be like this one we have already found, right? Which is
Okay, ma'am.
1.5.
Okay, okay, okay.
Your output will be like sine, or the omega naught value is nothing but half of t.
So, ma'am, only if magnitude is asked, so we have to just find this one only.
Only this, yes, only this value.
Okay, okay, ma'am.
This phi you can apply here. So this is if they are asked you to write the equation of VC of t. Here since only magnitude of VC of t, so 1.96. So till now it's okay. So yeah, basically you will expect questions like this only. For now we are seeing with the low pass filter, you can also like they would have asked you to find the voltage across this resistor. Otherwise, the same circuit but across here. But the equations and all are like similar. Direct applying, you can find the answer.
Okay, ma'am. And basically, we have to remember the formula and how to apply it.
Yes.
Okay.
We will also revise few other topics also. Yeah, these are the questions you have to find. The question is not small, right? You can see it. Yeah. So there are basically 10 questions with relation to this diagram. So basically, for power conventions, yeah, try solving it by yourself. If you have any doubt, you can ask. Tell me what is the voltage VA across the element A. So basically, you will be using KVL, KCL, power convention.
Ma'am, it will be 15 volts.
Yes, it is 15 volts. If you any of you have any doubt in any one of the question, do ask. What is the power absorbed by the element A? So this is V. This is the positive terminal, negative terminal. If the current is going out of the voltage source, is this power absorbed or power delivered?
I'm delivered.
Yeah, it is delivered. What about the resistor? Is it power?
Absorbing from current source.
So basically, there is a box from the current is coming out of the positive terminal, then it is delivered. There is a box. If the current is entering the positive terminal, then it is absorbed, right?
Absorbed, yes.
So we have found VA. VA is nothing but 15 volts. If you see 1 ampere, it is flowing in this direction, the same current, right?
Yes.
Is it coming out of the positive terminal or going into the positive terminal?
Out of the positive terminal. So it is a delivery.
So, but in the question they have asked absorb. So it is
Absorbed.
minus 15
That's what.
watts.
50.
Because it is actually delivering. But in the question they have asked absorb. So I'll just put it as minus 15.
Ma'am, why 15? We know the voltage across it.
Yeah, VA into I, right?
Yes.
We have found VA, right? 15 volts.
Okay.
And the current is 1 ampere.
Okay.
Now you tell me what is VB?
VB. 9 volt is coming and 10 volt is 1 volt.
Yes. What is the power absorbed by the element B? Absorbed.
Into R. 3 watts.
Yes. 3. Because it is entering the positive terminal. So it is absorbed only. So plus 3 watts. Then the current IC through the element C. How can you find this?
Current. We had to find the current, ma'am. So 3 ampere is
Yes.
coming and 1 ampere is going. So 2 ampere. 2 ampere, ma'am.
Yes. Then power absorbed by the element C.
Power absorbed. So voltage into current. 20 watts.
Direction. Is it absorbed or delivered?
Absorbed, ma'am.
Is it absorbed? See the current It is entering the negative terminal, so it is coming out of the positive
Okay,
terminal.
okay.
If
It is
coming
delivered
out,
by that C element. Yes,
so it is minus 20.
yes. So delivering is
Then
minus. Ma'am, delivering is plus now.
see, if the question they have asked delivered, then I will write it as plus 20. But in the question they asked observed, but the thing is
Absorbed by.
actually delivering.
Okay, okay.
Then what is ID?
ID. Okay. Current across the D.
The current ID. Yes.
Okay. 1 ampere is going through it.
It's simple, right? See,
1 ampere,
in this,
ma'am.
yes, 1 ampere. What is the power absorbed by the element D?
And yeah, 5 watts.
What is the direction? Is it a sign? Plus or minus?
Uh, from minus.
Plus.
Plus. Because see, it is entering the positive terminal. So it is actually observing. In the question also they have asked observed. So plus 5.
Absorbed by the D. Okay. I did not read that question. That's why I. Okay.
Okay. So first, once you see this type of circuit, first see this. If I, for example, C, you're taking this C block, plus or plus and minus, and the current is coming out, right? Once you see near that, you write it whether it is delivering or observing. Since it is delivering, I'll write delivering. But in the question, I will see. In the question, if they're asking observed and I
Absorbed.
have written delivered, if it is opposite, I will put minus. If
Okay.
I am putting delivered, in the question also it is given delivered, it is the same thing. So I will put plus.
It will, because it will always give from the positive. So if it is direction is positive, leaving also from positive. That's why we take it as negative.
Yes.
Okay.
It is delivered given here. Here it is given as observed. It is contradicting. So I am putting negative to indicate that it is actually delivering.
Okay.
Then what is current IE?
IE. It is a 3 ampere.
Yes, 3 ampere. What is the power absorbed by the element E?
-27. But direct, we had to mention direction, huh? So
Yes. Tell me whether it is observing or delivering.
it is delivering the man.
It is entering the positive terminal, no?
Yes, but 3 ampere is coming out of it. That
Yeah, it is entering. See, this terminal, it is entering. So it is observing.
okay.
Here also it is observing. Here also it is observing. So it is plus.
Plus, ma'am,
So
I
simple.
thought that 3 ampere is leaving. No, ma'am, 3 ampere.
Remember this.
Okay.
3 ampere is leaving the negative terminal, no? See with respect to the positive terminal.
Okay. So it delivers a current of 3 ampere
Yes. No,
across
it
it.
is observing the current of 3 ampere. See here. I is coming out of the voltage plus. The same
Yes.
I is entering the negative terminal.
Yes.
Here, I is entering the positive terminal. The same I is leaving the negative terminal. So
Yes.
have one thing as reference. Take the plus as reference. If the current is leaving from the plus terminal, then it is delivered. If the current is entering the positive terminal, it is observed. So
Okay.
whenever you write, take the positive terminal and see whether the current is entering or leaving. If it is entering, write observed. And in the question, if they have asked observed, both are observed, then it is positive. If it is contradicting, then it is negative. Is it fine?
Okay. Okay.
So yeah, please look carefully
Yes,
for
ma'am. I
power
had to practice
conventions.
more about it.
Yes, practice
Okay.
more problems.
Okay.
Then we will also discuss one problem with respect to superposition principle. So what you have to find is you have to find I. But when only 10 volt is energized, B is when only 2 ampere is energized, C when only 20 volt is energized. So
Okay.
this is, you have to use superposition principle to find this. Then you have to find the total, given all are energized, what is the total current?
Yes, ma'am. When we find the current due to the 10 volt source and due to the 20 volt source and 2 volts due to 2 ampere source, it is a opposite of that
You have to
direction,
just,
so we can minus it.
no, first go step by step, no? Find, when keep
Yes.
only the 10 volt, de-energize this and this one. What will happen if I de-energize a current source?
Yeah, it will
What
be
will
Middle.
open circuit and 20 volts it will be short circuit. So 5 ohm and 2 ohm is in series and 20 ohm is in parallel with it. And 3 ampere is not in work because 2 ampere is a open circuit.
Yeah, it's okay. You can calmly tell me the answer.
Okay.
Try it by yourself.
Ma'am, now basically week 7 is completed. We are doing revision now.
Yeah, so we have completed week 7 summary. Week 8 is, if you go through the lectures of week 8, it actually problem solving of these 3 weeks. So you will
Okay,
be
ma'am.
solving
Okay.
problem with the superposition principle, then that voltage divider rule, power absorbed,
Ma'am,
the
I
same
get
thing. But with,
Okay, ma'am. Okay.
0.6 amperes through that 10 volt source.
this is 0.6. Try it again. No?
0.65.
Yeah, please try it again.
Wrong? It is wrong.
Yes. A little point difference is there.
Okay.
Ma'am, 0.658.
You also got 0.658.
I also got that. Same.
I will check and I will let you know. Yeah, you can do the next question.
Okay.
By the meantime, I will check and let you know.
Using the 2 ampere source. You know, 2
Yeah.
ampere is given, na ma'am. Current through it.
Yeah, only when 2 ampere is given, you have to find I.
Ma'am, 2 ampere is also current I.
Yes, it is the current source.
Yes.
Only 2 ampere is energized. So you have to de-energize 10 volt and 20 volt. Keep only 2 ampere in the circuit. Find the current through the 2 ohm resistor.
Okay, across the 2 ohm resistor we had to find them.
Yes. Everything with
Okay. Okay, I find the current only due to the 10 volt source. Across the 2 ohm, I did not find that.
okay, you have to find I, which is given across the 2 ohm resistance. Now find and
Okay.
tell me what is I. Or maybe that's why the answer is different, I think.
Yes, ma'am. We had to just divide the current between that 20 ohm and that 7 ohm
Yeah.
using the
Try it
current
and tell
dividing
me the
rule.
answer.
Yes, okay.
Okay, I didn't mention it. The current is actually across the 2 ohm resistor. Since I gave
Okay.
it in the diagram, I didn't mention.
Okay, that's why I measure only because of 10 volts. So.
Yeah. It's okay. So here we'll be revising superposition principle.
Yeah, that formula, ma'am.
Then voltage division rule,
Yes.
current division rule. So from week 5, these okay series and parallel resistive networks, those are also there. Then RC step response, we have solved to 1 or 2 questions. Then filter type, we will solve more. Yeah.
Ma'am, we are going through
After
the revision for quiz
yes,
2.
yes.
Okay.
Hereafter, we will be having quiz to revision classes only.
Okay, ma'am.
So the reason why we like we actually took we started early, no? Week 5 we finished in 2 weeks. Week 6 also we finished in 2 weeks. Week 7 also we'll finish it in 2 weeks. So 2 classes. So the
Yes.
reason for that is so that we'll have more classes for the revision session.
Yes, ma'am. Ma'am, week 8 content.
Week 8 is actually problem solving. It has all the problems from week
Okay.
5, week 7.
Week, yes. Okay, okay, okay.
So
Week
that
5.
itself is a revision. So if you go through it, yeah, it will be a good revision.
Okay, ma'am.
Yeah. Tell me what is the answer for A when only 10 volt is energized? Yeah, did you guys get the answer? Or shall we start solving? Only when 10 volts is energized, right? My circuit will be 10 ohms, 2 ohms, 5 ohms. This will become open circuit. So the current will not be flowing through. Not this one. $20 ohms. So basically I want to find the current I. So these two are in series and parallel with 20 ohms and again series with 10 ohms. So R equivalent is equal to 10 plus 20 parallel 7 ohm. Then you can find I total. That is nothing but 10 volts divided by R equivalent. Then to find I, you can use current division rule, right? That is 20 by 20 plus 7 into I total. Did you guys get the answer? What is the value of I?
0.487.
Yes, exactly. It's 0.487 amperes. Now, only when 2 ampere is energized. Keep only 2 amperes. Tell me what is the current through the 2 ohms.
Point 731.
Okay, what is that? Yes, 0.731. Only 20 volts is there, then what is the answer?
$1.46.
Yes. Then what about the total current? So the current here also will be flowing in this direction. The current due to this will also be flowing in this direction. Current to this also will be flowing in the same direction. So you can just add, right?
Yes, ma'am.
What is the total current?
2.68.
Yes, 2.68. So what is the voltage? Resistor 2 ohm given. I have found voltage across the resistor.
5.36.
Ohms. 5.36 is. Yeah. So basically we have revised Ohm's law, KVL, KCL, power convention, superposition principle, then voltage division rule and current division rule. Then A is equal to minus 10. So this is my V in. So basically this is a circuit. It has like, first I am giving only V in as 2 millivolt. What will be my V out?
Minus 20 millivolt.
Yes. What about when I give V in 2 as 2 volts? What about my V out 2?
Minus 20.
Will it be minus 20 volt? See,
Yes, ma'am.
it is
No,
powered by
no, no.
8 volts. It
Okay,
will not
okay.
be equal
So,
to minus 20. It will be something less than 8 volts only.
okay.
What about my V in 3?
Ma'am, so it will be 20 millivolt plus 20 millivolt.
Plus 20 millivolt. What type of if amplifier is this?
Inverting.
Plus, it's inverting amplifier. Yeah, did you guys have any doubt in any of the questions which we saw today or today lecture?
Ma'am, this question is from week 5 or 6.
Week 6 amplifiers.
Okay, ma'am.
So basically there are two types of amplifier. One is inverting amplifier, another one is non-inverting amplifier. If it is an inverting amplifier, V in will be equal, V out will be, for both the amplifier, V out will be equal to AVA. For inverting amplifier, A will be negative value.
Yes,
For
ma'am.
non-inverting amplifier, A will be a positive value. That is the difference.
Okay, ma'am.
Yeah. So we saw about amplifiers, we saw about the superposition principle, then power conventions, then we saw about the low pass filter questions with respect to a step voltage and also a sine input. Do you guys have any other doubt in today's session? Or if you have any doubt in the practice assignment, graded assignment also, you can tell. If possible, I will solve it today, otherwise we will see it in the next session.
What?
If you have any doubt in practice assignment, activity questions also, you can tell.
No, ma'am. Ma'am, because yet I have not completed week 7 content. I have to complete.
Okay. Yeah, okay then. Go through week 7. You can go through
And
week
then,
8 also.
ma'am, in this
Yes.
week, only the next EST class is only on Saturday, not on like who that?
What happened?
Ma'am, in this week calendar, ESTC class is showing directly after Monday on Saturday, not before that.
Yes.
So
Yeah, you will not have classes in between. You will directly have class on
okay,
Saturday.
ma'am. Okay, ma'am. Okay, ma'am.
That is also a revision session. You will be discussing all important topics that day.
Okay, ma'am. Okay.
Then
Thank you, ma'am.
next week also, we have your quiz on November 23, right? So we have one more week.
Yes, ma'am.
In that one session will be for mock discussion. The other 3 section will be problem solving and revision session only.
Yes, ma'am.
So start watching week 7 and week 8 lectures fast. Complete graded assignment also. Then
Yes,
start doing
ma'am.
your revision as soon as you
Okay,
can.
ma'am.
Yeah.
Ma'am, so what will be
Yes.
the syllabus for quiz 2?
Syllabus for this is week 5 to week 8.
Okay, ma'am. Okay, ma'am. Ma'am, so I think so in quiz 2, only ESTC will come, na? C programming will not come, na?
That is how, that depends on what exams you choose to write, right?
Oh, okay, ma'am. Okay, ma'am. Thank you, ma'am.
Yeah, thank you. So yeah, thank you guys.
Thank you, ma'am.